So, hi guys, how are you all? I hope all of you are doing good. I'm sorry, due to some technical issues, we are late for 3 to 4 minutes. So, let's begin. So, first of all, you can just write in the chat that if you can hear me properly and if you can see me properly on the scale of 1 to 10, that is 1 for the worst and 10 for the best. So, you can just write down in the chats, and also you can just write down where are you from, and you can just write down your names also so that I can interact with you also. Right. So guys, you can start. Okay, so we'll be starting. First of all, I just want to ask you, how is your preparation going on? Is your preparation going on really, really well, or it is okay, okay? And or the third, that is, it is, or the sad face, you can say that it is not going that well if you are not okay. You are from Hyderabad. Hi, Saikaran. Peace, Saikaran. Am I spelling the name right? Okay, so Saikran, how is your preparation going on? So you can just write in the chat one. May I know why and which topics are you lacking in, at especially from chemistry point of view? If I ask you, okay, okay, Ashrita. Hi, Ashrita. So, Ashrita, you can also write that how is your preparation, and you can just rate it from 1 to 3, and you can just write that if your preparation is at first level, that is you are not happy with your preparation, even that you are saying that I always lack in these topics, right? And I do not I cannot do that, and I face these problems in such topics, and you can just write that, and we can just help you out, and I will just discuss how you can remove that and how you can jump from this level 1 to level 2 and then level 2 to level 3, right? So hi Ashita, hi. So okay, so you can just write down what is the level of your preparation, and if you are, and which colleges are you preparing for, and you can let me just introduce myself. I think you guys know me. My name is Khushang, and I gave JEE few years back. So I prepared for JEE at that time. So I have gone through this stage of yours from a very very few short interval of time, right? So it is not a very large interval of time, so that I have lost touch to that preparation phase. So I know that students face, we guys face some problems, and that also you can just treat me as your elder brother, and I'll just guide you how you can prepare for JEE, and which topics you lack in. I know that because I also prepared, and I know which topics are difficult to students, which topics cannot be explained by such. Okay, you are lacking in organic chemistry. The preparation was okay. Okay, okay, okay. So now if you was lacking in organic chemistry, right? You were lacking in organic chemistry. Now is your organic chemistry fine, or you need some more tips and you need some more preparation guides? See, for organic chemistry, first thing is NCRT. You just read down to the NCRT. You can just write down the important reactions in your notebook, right? So you can just make notes. As I always say that these notes will be a lifesaver, right? So you can just make notes and you can just revise it again and again, so that these reactions will be in your head all the time. You can just paste it on your study table. That's what I did, and so I learned these organic reactions. Actually, when we study organic chemistry, right, so we just dive into how these reactions are happening. We know the reasons of why these reactions are happening, right? But after a short interval of time, we just, what the important thing is that we remember the reaction, that which two compounds will react and form a product, right? So the type of product matters and the type of reactants matter. So you just have to remember those reactions, and in the back of your head, obviously you have uh, studied about why those chemical reactions were happening, right? So it will not be a huge amount of work if you have revised those reactions again and again and again, that you revise that these alkanes react with these oxides or anything these like, and they are forming this type of product, right? For example, I'm not diving into a such particular topic, but I'm telling you that you are remembering that this is the type of reactant, that is alkanes react with such compounds to form another these types of compounds. So you have remembered a general equation, right? So you've remembered a general equation. Now you can just see the question first. The reactant alkane, you can just remember that the alkanes reacted with such types of compounds to form that product. So you can just relate to that and you can just solve the questions. I know organic chemistry seems very difficult, and organic chemistry, if I tell you the truth, organic chemistry, teaching organic chemistry is that difficult only. It is not easy part. So I'm just telling you that you just remember those, you just make notes and paste it on your study table. And it is not just for organic chemistry, it is for inorganic chemistry as well. Today also we are going to start inorganic chemistry. One topic we are going to start, that is P block, that is boron family. So I just request you all guys to take a pen and a paper in your hand and you just make keep on making notes, right? So important reactions and exceptions. Main thing in inorganic chemistry is exceptions. So you just note down the exceptions and you can just paste it on your computer table or your study table, and just you can just remember it while passing through that table, right? So these things will be in your head, so you will not be. So we want some classes from you in organic chemistry. Okay, so in the next class will be of organic chemistry. The next promo class will be surely of organic chemistry, and we'll be studying organic chemistry together. And I am sure you will find it very easy. That organic chemistry is not that difficult that we were thinking of it, right? So firstly, moving forward, we have talked enough. So about me, I have told you that I gave JEE few years back. I secured 99 percentile in JEE. I have completed my BTech from one of the most prestigious institutes in the nation. I'm not bragging it, but I am just motivating you all guys to do that, right? So if you get into a government engineering college with a good rank, that is, if you secure a good rank, you will be getting the engineering stream of your own choice. That if you want to go for computer science, you will get computer science branch in a good IIT, DTU, NSIT, NIT, BITS. So if you get into one of these colleges having the stream of your own choice, is many students have many choices, right? So my choice was computer science. So I secured a rank so that I can go into this my dream college and I can study computer science there, so that I can do some software development work and get into a good MNC, securing a good packages, high amount of packages, right? So you must be asking, then why, what are you doing here? So I am just following my passion, because while preparing for JEE, I just have it in my had it in my mind that these things professors which we study in big coaching institutes are not able to explain us. These things I uh, learned from my friends, some my other teachers, some tuition teachers, right? Because in schools you guys also know that that level of preparation is not possible. So I know which types of problems I face. So I just had it in my mind that if I get any opportunity to tell my stories, how I prepare, tell what things are there that you can remove, so that you can just go with the flow in your preparation, right? You do not face the difficulties which I face. That is the reason I am sitting here in front of you guys teaching chemistry, because I like the chemistry most, and even I like physics also. I have secured 109 marks from 120 in JEE mains. So we'll be moving ahead, and we'll be I'll just explain you guys already know what is our course, so I'll explain you briefly about it. So you will be having live classes. Before the live class, you will be having some study material. So before the live class, you will be solving the study material, and you will be just reading the study material what is going to be there in the live class. You have read it once, you know in the back of your head that these are the things which we are going to teach and which we are going to discuss in the class. And when you read that, obviously you will get into your mind that these things are not clear, right? These things are not clear in my head. So when we discuss those topics which you already had in your mind, so these topics will be more clear to you, and you will be just, and after the class, even after the class, I'll be giving you some questions. You will be solving those questions on your own, by honesty, right? And then you will be seeing the solution video which I'll be making on those questions even, right? So it is known as the flipped classroom method. We discovered these methods. This is used in some foreign universities, Oxford even, and this is a very very efficient method. And yes, that's it. So today we'll be moving on and we'll be studying with p block compounds. We'll be starting p block compounds, and especially in the p block compounds we'll be starting with boron family, right? So I just request you to take a pen and a paper in your hand, and just you can just make notes and start writing what I'll be telling you, right? So the p block elements, which elements are the p block elements? First, what is p block, why they are known as p block? So the elements having the p orbital in the outermost shell, you can just write down elements of the periodic table having as their outermost shell in which electron enters, right? So when you write the configuration, right, when we write electronic configurations in which and we write some configuration, for example 1s2 2p2 something something something, for any configuration, right? And in the last, if we have p, and you know, already know that p orbital is having three boxes in which six electrons can be there, 1 2 3 4 and 5 6. So we have six options, 1 2 6. So if 1 to 6, any this type of configuration is there from in which the last is p, and 1 to 6 any is written, any number is written, right? So that element are entered, that element are from the p block, the p block in the periodic table. That group is known as p block elements. So one more thing, you can just write down that we already know six electrons are there in p block, or p, you can say orbital, right? We already know this, right? So so six electrons are there. So in the p block we have six groups. Due to these six electrons we have six different groups, right? So if you are able to understand, and if you can just get me, right? So you can just write down in the chat that yes, we are hearing you properly, and we can see you properly, and we are understanding what you are telling us, right? So I'll be somewhat motivated, right? So six electrons are there in the p orbital. We have three different boxes, we can enter six electrons there. So if there is a there is an element having p1, so it will enter different group. If we have p2, then it will enter different groups. Similarly p3, p4, p5, p6, right? So these configurations having are classified into different groups. For example, we are studying today boron family, right? So boron family is the family having configuration in the last is p1. So it is a family in its own, it is a group, right? And then for example, in the carbon family we'll be having p2, so it will be a whole group having the configuration in the last as p2. So we'll be noting one more thing down, that is I have already told you we have six groups, right? So what are these groups from? You know, in the periodic table we have already studied there are 1 2 3 4 and like 18 groups, right? So in the P block, the P block is classified from 13th group to 18th group. This is the whole part, this part, the 13th group to the 18th group, from the boron family to the noble gases family, right? It is all P block elements, right? These are all P block elements. So today we are going to start with the 13th group, that is the boron family. And one by one we'll be moving ahead and we'll be studying more families together as a family, right? So what is the boron family? What is the group? So that is boron, aluminium, gallium, indium, helium, and UUT, that is the radioactive. So this is not important. We have to study it here. So you'll be saying that how we can remember that, and you guys have already studied that. So I will also tell you one trick to remember this. That is bangan, aloo, gajar in theli. Bangan, aloo, gajar in theli. This is the trick to remember the boron family itself. So what is bangan here? That is boron, aluminium, gallium, indium, and helium. This is the trick to remember the boron family, and you can just note down trick to remember. Trick to remember. Right. So you can just make your own abbreviations also, so you can remember everything. As I always tell you, in every, you can say in every class, in every chapter, I tell you some shortcuts and some short tips to remember that. So this is one of that. So bangan, aloo, gajar in thali. So you can just remember the boron family from here. Boron, aluminium, gallium, indium, and thallium. Okay. So now the question arises, why are we studying this? What is the need? Why we study this? What is the use in real life, right? So it has many uses. We do not have a huge amount of spare time. We have to study about each and every element which is of no use, right? So boron, if we talk about boron, we have many uses of boron in our daily lives also. So boron is used in bulletproof vests, right? It is used in, you can say, aircrafts. It is used in nuclear reactors too. Nuclear reactors. None of you are commenting down anything. And it is used in antiseptic medicines too. Antiseptic. It is used as antiseptic too. Antiseptic and steel industry. Steel industry. So much of use in our daily life. That is why we have to study about this element, right? Another is aluminium. All of you know about aluminium, so we'll be writing down some uses of aluminium, right? So we'll write down aluminium. Okay, Renuka. Okay, so we'll be writing some uses of aluminium. What is the use of aluminium? This element you yourself use in your daily lives, right? When in you use aluminium foils to wrap food, right? So aluminium foils. Okay, write down foils to wrap food, right? We use in airplanes as it is a very lightweight metal. Airplanes, we use it as alloys. You must have studied about aluminium wires also. Wires, as it is a conductor too. It is used in utensils also. So much of uses, and similarly the uses of other elements are also there, though these two elements in the boron family are found in abundance in our earth crust, right? This aluminium is in such a abundance that it is about 6% of the whole Earth's crust mass, right? So other elements have also have so much of uses that we need to study about them, and we have to study about the characteristics, we have to study about the chemical properties of these compounds, and like we studied in periodic table, the trends in the p block family, in the trends in the boron family, we'll be studying. Okay, so as I have told you that in the last, in any p block element, the last configuration, the configuration in the last p comes. So what will be the you can say general configuration of any element in p block? So general configuration, we'll be writing general configuration. What will be the general configuration? It will be ns2, as there are two electrons in the s orbital, it is completely filled. Then p orbital comes, so we have six choices here. So n p 1 to 6, this will be the general configuration of any p block element. Any p block element, this will be the general configuration of any p block element, right? So now we'll be writing the whole p block, and I'll tell you a very interesting thing. First thing is that all of the three metals, non-metals and metalloids, all of the three are found in the p block, even gases too, right? So all of them are found in p block. And one more thing is that the first element of each group is different, somewhat different. It shows some different properties, some different physical properties, some different chemical properties from the rest of the group, right? So for example, we have seen the boron family. So it was a 13th group, it is a 13th group of the periodic table, right? So boron shows some different physical and chemical properties from its group, that is the other elements. Yes, yes. Okay, not ns2 np6, we can write down ns2 and np. Any number can come here. If there is ns2 np1, one second, I'll explain you what I am trying to say. That is, for example, we have ns2 and np1, this is the general configuration of the boron family. If we have ns2 np2, it is the configuration of carbon family, and such that. And in the noble gases we have completely filled orbitals, that is ns2 np6, so it will be the noble gas configuration, and all of the you can say electrons are filled in the p orbital, right? So this was I was trying to say that if we write the general configuration of any element in p block, it will be ns2 and np 1 to 6, right? Okay, so I hope you guys have got that, and if any doubt is there, you can just write down in the chat section, I'll be replying to you. Okay, so now we'll be writing the whole p block. What is p block and which elements come in that? First there is the 13th group, then 14th, 15th, 16th, 17th and 18th. It is from 13th to 18th group. First there in the 13th group is the boron family, then the carbon family, then nitrogen family, then oxygen family, right? We'll be writing Al, Ga, bangan, alu, gajar in Heli, right? Carbon, then silicon, then germanium, then tin, then lead. Here it is not coming. uh what is not coming? Can you please just, okay, the option will be there, you can just try it once more. No problem, Cyclone. Okay, so we'll be continuing that. This is the third 14th group. Then the 15th group comes nitrogen, phosphorus. Then then it's B, and there is Bi. Right. Okay. Okay. Then in the oxygen group, sulfur and selenium, Pe, then At. Then in the 17th group, we'll be writing with that is the halogen group, fluorine, chlorine, bromine, that is iodine, and okay, I have made a mistake here. Here At will come, and here polonium will come, Po. Then there is the noble gas group, neo, argon, krypton, and Rn. Okay, so this is the whole P block, and here the radioactive elements come, UUT, UUP. We don't have to we don't have to focus on them, right? We have to just focus on these elements. Now I'll be telling you that I told you that in the P block we have both, all the three types: metals, non-metals, and metalloids. So if I use a highlighter and I just highlight what are the metalloids, this boron, then we have this silicon and germanium too. Silicon and germanium. There is a very interesting thing going on here. You'll see. This germanium, then arsenic, and Sb2. If I go through the diagonal, then Te, and then At. You can just see a staircase design, right? So in the highlighted, all of them are metalloids. These are all metalloids. And if we go down this diagonal, that this AlGaIntn, this SnPb, all of them are metals. And if we go above this diagonal, all of them are non-metals. All of them are non-metals. Yes. So I think you have got that. The highlighted, this diagonal, in this diagonal, every element is a metalloid. If we go down the diagonal, every element is a metal. And if we go up the diagonal, every element is a non-metal. So you can just note down, you can take a screenshot of this and you can just note down in your notebook, right? It is a very, very interesting and important thing. You can just know which element is a metalloid, which is metal, and which are metalloids. Talking about this 18th group, these are gases, these are noble gases, right? So I have told you these are non-metals. Above the diagonal, non-metals, down the diagonal, metals, right? So one more thing. If you move on to the next page, I'll be writing another trick. बच्चे सीता गीता आस्था सबको टेनिस आता. This is the trick to remember what? Trick to remember metalloids. बच्चे सीता गीता आस्था सबको टेनिस आता. We'll be moving back. बच्चे सीता गीता आस्था सबको टेनिस आता. So by this line you can just remember about the metalloids, and you can write the P block on your own. Then you can just write this बच्चे सीता गीता आस्था सबको टेनिस आता. You can just highlight all the metalloids. Now you know above this diagonal every element is a non-metal. Down this diagonal every element is a metal. So now you just know which element in the P block is a non-metal, which is a metal, and which is a metalloid. You cannot just take any chance of not solving any question asked from this type. That if the question asks that which of them is a metal, which of them is a metalloid, which of them is a non-metal, you will just tick on your own. You are not required to remember anything. You just require to remember this trick. You know these are the metalloids. Above them are non-metals. Down is metals, right? So everything about this is done. Now we'll be writing some interesting facts. I hope you guys have noted down this. So we'll be writing some interesting facts. We'll be erasing this, right? First, boron. In the boron family, we'll be studying. What was the boron family? Bangan, aloo, gajar, in, Delhi. Right? Up to now, I think everyone remembers what is the boron family, and you can write that. Right? So boron, this first element, is a fairly rare metal, non-metal, fairly rare non-metal. Now you will say that you were saying that it is a metalloid. Actually, boron, as it is the topmost element, I always told you that it shows some different properties. So it shows both metalloids and non-metal character. Boron shows both metalloid and non-metal character, right? So it is a fairly rare, that not very rare. It is found in a, you can say, noticeable quantity in the earth's crust, right? Next, aluminium. It is the third most abundant metal. It is the third most abundant metal in the earth's crust. That is, it is 8.3% by mass. I have told you in the solutions chapter what is percent by mass, percent by volume. So that is 8.3% by mass. So if the Earth's volume, Earth's mass is 100 grams, it is 8 grams of that. So you can just imagine what is the mass of Earth. You cannot imagine, we cannot imagine, and it is 8.3% of that aluminium only. So you can just know how much is the abundance of aluminium, how much quantity it is present in the earth's crust, right? So we'll be moving ahead, and we'll be writing the general configurations of the boron family. So I just request you guys to write the configuration of boron in the chat. Write the electronic configuration of boron in the chat. I'll be erasing this, and then I'll be writing that. Okay, so you just write the configuration of boron in chat. What is the P block? That is bangan, aloo, gajar, in Delhi. Right. So no one has written down the configuration of boron. I'll be writing now. Okay. Configuration is helium in the first. This is how we write the configuration, the noble gases configuration, and you can just expand this too. Okay, we'll not be writing this type of configuration. We'll be writing the full configuration. NS2 NP1. Renuka, I am asking the configuration of boron. You have to write what is N here, right? So what is the atomic number of boron, and then you have to write that. Atomic number of boron is 5, right? So N will be okay, I'll write. So you have written down NS2 and NP1. No, it is not right. You do not have to write N here, right? So the configuration of boron is 1s2, 2s2 and 2p1. This is the configuration. Obviously the general configuration was ns2 and np1, but the number n here is 2, right? So now okay, no problem. Now you just write the configuration of aluminium in the chat. Aluminium in the chat. Ashrita, ns2 np1 is correct, but it is the generalized configuration, right? It is the generalized configuration. If the atomic number of boron is 5, so it is having 5 electrons, right? So first the s orbital will be filled and 1 s2, then it will come to the second shell is having s and p orbital, then the first s will be filled and 2 s2 second shell, and will be 2 here, then one electron is left, it will be filled in the p orbital. So the general configuration will be 1s2 2s2 and 2p1. Now we'll be writing the configuration of aluminium, right? So it is 1s2 2s2 2p6 and then 3s2 and 3p1. Now n becomes 3 here. Got it? Renuka and Ashrita, have you guys got that? You can just write in the chat section. Right. So we'll be moving on to gallium. Now we'll be writing the configuration with noble gases. It is really easy to remember, right? So how we can write, okay, I'll be erasing this and we'll be writing the easy configuration. How we can write it easily. We do not want to do hard work, we need to do smart work, right? So first we'll be writing the noble gases configuration and the rest is the generalized configuration. So what is the boron's configuration? He, then 2s2 2p1. Now next noble gas Ne, then 3s2 3p1, then Ar, 4. Now when here, one second. 1s2 2s2 2p6 3s2 3p1. Right. It is absolutely correct. Okay, you are writing the configuration of aluminium. It is absolutely correct. Good, you got that. Okay, so we'll be moving on. We'll be writing the configuration of gallium. Then we'll be writing Ar. Here the d orbital comes 3d10, then 4s2 and 4p1, right? Then we'll be writing the configuration of indium. It will be, the next noble gas is Kr, then 4d10 5s2 and 5p1. Ti, it will be Xe, 4f orbital comes here, 14 electrons are there, 5d10 6s2 and 6p1. So these are the general these are the electronic configurations of the boron family, right? I hope all of you have got that, how we have written these electronic configurations. And if you ask that, I'll tell you what problem I face, that why we write these noble gases here. Actually, in noble gases, you guys already know, no valency of electrons is there, every orbital is completely filled, and when we write the general configuration as Ashita has written here, you can see in the chat, that is 1s2, then 2s2, then 3s, then 2p6, then 3s2 and 3p1. Okay, so up to here, what is the electronic what is the atomic number of neon? That is 8. What is its electronic configuration? Every electron and every orbital will be filled. It will be 1s2 2s2 and 2p6. So we do not have to write the completely filled orbitals again and again. So instead of that, we use noble gases. So we can see here 1s2 2s2 2p6, and in the neon 1s2 2s2 2p6. So we write neon here, and then we write the electronic configuration of the outer shell. You guys got that? So this is why we use the noble gases first, and then we write the configuration. Okay, now we'll be moving ahead and we'll be going with the trends. Which types of trends? There are two types of trends: physical properties and then chemical properties, right? First we'll be moving to, it is a very interesting thing. Now it is coming that in everything, in every configuration, in every trend, there is an exception. And one thing I'll tell you, that why these exceptions are coming. One, everything will relate to that. Everything, you will be getting answers of everything if this thing which I am going to tell you right now is clear in your head. First we'll be writing we'll be checking the trend of atomic radius, right? Atomic radius will be moving on. As you guys already know, we have already studied in the in the periodic table. So you can just write in the chat that when we go down the group, what happens to the atomic size? Atomic size, does it increase? Okay, we can just make it a question. First option, increase. Second, decrease. Third, can't say, anything can happen. And D, first increase, then decrease. Right? So if you know the answer, you can just write in the chat. Renuka is saying increases. Ashrita, what about you? What do you say? You can just write down in the chat your answer, A, B, C or D. Right? Then we'll be moving ahead. Okay, we are moving ahead. We do not have much time to waste. Right? So the answer to that is increases. Increases. Good. Renuka. Right. So the answer is increases. When we go down the group, the atomic size increases. So what should happen? Now we'll be writing what should happen. If any one of you know the exception, what is the exception here, you can just write down in the chat. If you have revised and if you have read the chapter, you can just write what is the exception in the atomic size in the boron family. Any one of you know? I'll be just writing in a bit. Right. So what should happen? What should have happened is, firstly we'll be writing bangan, aloo, gajar in Delhi. Right. So atomic size should have increased. Atomic size should have increased. That is, boron size should be the smallest, then aluminium, then gallium, then indium, and then helium. But it is not the case every time. But it is not the case. Right. So if Renuka, if you are saying no, what is the exception here? What should be the correct you can see the correct sequence? What is the exception? You can just write down in the chat. Okay. So we'll be moving ahead. So when we studied that what is the atomic radius of each and every element, right? So what we got is, when you will study this, the NCRT of the chapter is P block, you will get a table in which the atomic radius of this P block, that is boron family, is given, right? So you will just see what is actually happening. I'll be writing down that table for you. So atomic radius comes here. Renuka, what is the exception? You are saying that no, it is not increasing from top to bottom in the boron family. So what is the exception here? Which element is smaller and comes under the other element? This is my question to you. Right. Ashita, you can also think and search about that. Okay, so we'll be moving ahead. If the here atomic radius comes, now I'm writing bangan, aloo, gajar in L. Right. So I'll be writing the atomic radius of each and every element. First there is 85, then 143, then 135, then 167. I don't know the correct order. Okay, no problem. We are I am telling you what is the correct order, right? So 167 and 170. Now you see here, the size of gallium is smaller than that of aluminium. Why? The question arises, why? Now what I'm going to explain you, the reason I'm going to explain you, please hear it very carefully and please make notes of it, because each and every exception will be coming from this part only, right? So what we got is the atomic radius of aluminium is greater than that of gallium. But what should it be? When we see the, when we thought and when you guys also wrote that the atomic radius increases from top to bottom, so the gallium size should have been greater than that of aluminium, but it is not so. Why? The reason is here. When we come on to the where the electronic configurations, I wrote the electronic configurations. Okay, we'll be writing the electronic configurations once more, but in a very short interval of time. On aluminium, gallium, indium, thallium, electronic configuration is He 2s2 2p1, then neon 3s2 3p1, then gallium, argon 3d10 4s2 and 4p1, then indium on 4d10 and 5s2 5p1, then of is xe 4f14, then 5d10 6s2 and 6p1. So when we write these electronic configurations, we know the size of gallium is smaller than that of aluminium. Why? See, here s and p orbitals were involved, here s and p orbitals were involved. When we come here, what is the exception here? The exception is this d orbital. The d orbital comes. So you will be saying, sir, if the d orbital is there, what does it make any difference? Does it make any difference? So does it make any difference to the size, right? So why the presence of why due to the presence of d orbitals, the size of gallium is smaller than that of aluminium? Okay, I'll be explaining you. If I take an example, right? So if there is this mic, you can see this mic, right? So there is a filter in the front of the mic. I am saying something and the voice is going to the filter and then to the mic, right? So the voice is somewhat you can say is getting filtered through this filter and getting to the mic. If I remove this filter, then my voice is directly going into the mic. Then I add the filter, some voice is left out. Then if I add a wall here, I add a complete wall here, and then I speak, I don't think my voice will reach the mic, right? Similarly, if I take a fan and keep it here, I'll be experiencing the winds directly. Then I place you can say a thin paper between me and the fan. Then somewhat less air will be received by me. Then if I add a complete wall between me and the fan, then no air will be experienced by it, right? So similarly, when we talk about atoms, right, if we talk about the atom, we have the nucleus here and the electrons are revolving around. So if the electron is here, you guys already know nucleus contains what? Protons. Nucleus attracts these electrons towards itself, but this force is shielded. You can say that for example, I took the example of the you can say the thin paper or a wall. So the air was shielded from coming to me through the wall, right? So similarly, this force which the nucleus is applying on the electron, it is attracting the electron. This force is shielded by the s and p and d orbitals. All the orbitals, you can say, they shield this force. We have studied in the chemical bonding chapter that the shielding effect shielding effect of d and f orbitals are very poor. So you can compare the you can say d and f orbitals to the thin sheet of paper between me and the fan. So I was experiencing somewhat less air, but I was experiencing the air, right? And you can consider as s and p orbitals are very good at shielding, so you can consider them as a wall. So they just cancel the attractive effect of the nucleus, which the you can say the force on the nucleus, the force on the electron which is applied by the nucleus. These are shielded by the s and the p orbitals very you can say nicely, and the d orbitals are somewhat less efficient to shield that. So when d orbitals come in place, the shielding effect, or they cannot shield the complete attractive force. So if they are bad at shielding, some force is experienced by this electron. So if the attractive force is there, so somewhat electron will revolve in a lesser orbit. The outermost electron will revolve in the lesser orbit due to that force. Force is always there, but shielding is affected by s and p and then d orbitals. If d orbital is there, the shielding effect is very poor. So the force is directly applied to the electron. It revolves in somewhat lesser radius orbit. And if s and p were there, there is not that much amount of force is applied on the electron that it shifts its you can say revolving orbit. So in gallium, d orbitals come, and you know that the shielding of d orbital is poor. So more force is applied on the electron, lesser is the revolving orbit. So that is why, due to the presence of d orbital, the radius of gallium is smaller than that of aluminium, because in aluminium only s and p orbitals are there. They are shielding the effect from nucleus to the electron really well, and in the gallium d orbitals come which are poor at shielding. So more force is applied on the outermost electron, so it revolves in a shorter orbit, you can say orbit of shorter radius. So I hope you guys have got that. If yes, you can just write down in the chat section. It is a very interesting topic, and every exception is solved by this topic itself, that is the d orbital shielding. Okay, Renuka and Ashita, you can just write down. Sir, then indium also have d electrons. Why don't it have exception? Okay, indium and okay. One second. Firstly, in indium, the fifth shell comes, right? First of all, boron, aluminium, and gallium. All obviously the size should increase, right? Size should obviously increase, but due to the presence of poor shielding effect, the size of gallium is somewhat smaller than that of aluminium. Then comes indium, which you are asking. In indium, the outermost electron revolves in the fifth shell. Obviously it has d electrons, it will have poor shielding, electron will evolve in less, but kitna less हो जाएगा, right? The question is kitna less. If the atom is very big and poor shielding is there, the nucleus effect is somewhat that it will reduce the orbit in a very short, you can say it will decrease the orbit very shortly. In same case of gallium, it decreases the orbit very shortly, and it becomes smaller than aluminium. But in indium, the fifth shell comes. When the fifth shell is there, when the d shielding occurs, it becomes smaller. You can say one more thing. When I wrote about the sizes, see here, the indium and thallium, there is one more exception in this. See here, when the boron size was 85, then becomes 143, a huge increase. Then a small decrease, 135. Okay, this was due to d orbital shielding, right? Then comes the indium. Size increases. See, not a very huge increase first of all, 135 to 167. Then only 170, only 3. Why this is so? This is due to f orbital. D and F both, you can say. F orbital poor shielding effect. Because in Ti, P orbital also, F orbital also comes in place. F orbital is there. You got, Ashita, you got that? Then obviously, if the size is increasing, more electron is increasing. When we move down the group, the atoms become bigger and bigger, right? It has a, you can say, greater atomic number, greater size, more shells. But due to poor shielding effect of d orbitals, the size becomes somewhat smaller than aluminum. Then we come on to indium. It has fifth shell too. So the size will increase. Obviously, it will increase because a new shell is introduced. And the poor shielding of d orbital, it happens, and that is why there is not a huge increase, 135 to 167 only, right? And then f orbital comes, one more shell comes, the size should become very big, but due to poor shielding of f orbital and d orbital, the size remains almost the same. Actually, these 85 143 are in angstrom, that is 10 to the power minus 10 meter. So you can just imagine, you cannot even imagine how much small the radius is, right? And it is almost the same, 167 and 170, right? You've got that. I think you got that. Okay, sir. Okay, Ashita. Okay. Renuka, have you got that? Okay, I have explained you about d orbital shielding, f orbital shielding, and okay. Okay, Renuka. Good. You guys have noted down in your notebooks. You have made notes about this, because the exceptions will be the next exceptions we will be studying in the next class, and you have to just revise this, what exceptions we have studied today and what is d and f orbital shielding. You have to go and open the ncrt. You can just read down what we have studied till now, and you can just see the table also, which table I am telling you, and from which table I have written down those numbers, right? You will understand what is actual meaning and what we discussed today, right? So moving ahead, we'll be okay. Okay, Renuka. Okay, good. So that's it. Today we'll be studying only this much. I'll once more tell you about our classes. I've told you we'll be giving you theory first, then study material. These are the theory. Then we'll be having a live webinar. Then there is a homework, and there's a homework checking will be there. I'll be explaining you the solution also. You'll be scoring in the test we'll be giving to you. The test will be on our proper site. It will start from a specific time duration, and you'll be solving the questions. And we have three types of courses, that is light course, smart course, and proficient course. These are very cheap, I am telling you. These are really cheap when we compare it to big institutions, right? So we as youngsters have created this course for you guys, so that you do not face the problems we faced, right? I have told you about that. I'm not repeating that again and again. So we'll be in this I'll be suggesting you about the smart course. You take the smart course. Here we'll be having interactive live courses and PDF we'll be providing you. We'll be having live tests. We'll be providing you physical notes too. Then one-to-one mentorship. Anytime you'll be added to WhatsApp groups too. You'll be having our numbers too, and you can just interact from us. You can just ask questions. You'll be having live doubt solving there only. Mock test will be there. They are very important. We'll talk about the importance of mock tests in our coming classes. So this was a free lecture on YouTube, but these are the proper plan in which we'll prepare you for your JEE exam, and you will be surely securing a very good rank and very decent numbers, and you will be securing a good college. I am guaranteeing you that. Okay, okay, guys, that's it for today. See you soon. Bye bye. Love you all.